The question, if I tried to disguise it, it is binomial. But it doesn't look like it's binomial because I've got 3 bags. But the key bit to know that it could be binomial is that they're replaced. And that replaced is quite important because it tells me the probabilities remain the same. I'm also doing it 5 times, which is going to be a huge amount of drawing for a tree diagram. So a ball is drawn 5 times from the bag. So n is 5, and each time it is a yellow ball. 5 choose 5, and we're doing probability of a yellow ball is 6, and we have how many balls do we have? 11. 6 out of 5 is 11, 14, and we know that is occurring to have to happen 5 times, and then so what's left over? We have 8 out of 14, and that's not happening at all. So we work out, so we say P x is equal to 5, and you could say x is yellow selected if you wanted. And on the calculator, well, all I'm going to do on the calculator is to menu 55D and put n to be 5, probability 6 out of 14, or you can simplify that down by dividing through by 2, so 3 over 7, and the x value is 5, and I get an answer of 0.0144582 and fix. That's worth 2 marks. Part B. At least one red ball is chosen after drawing a ball from the bag 8 times. So I need at least, I'm going to say y is red ball selected. So I need to have at least one yellow ball selected. So that's equal to 1 minus the probability. And there's more than one way of doing it. I'll explain as many different ways as I can. That means 1 minus the probability that there are no yellow balls selected. So what's the probability? Oh, I've not yellow, red ball selected. Maybe I should have used an R rather than a Y. So 1 minus the probability of that. So P of y is equal to 0 is equal to, now we're choosing the ball 8 times, we want in none. The probability of getting a red ball is 3 out of 14. We want that to happen no times. And what do we have left over? We have 11 out of 14 left over, and that's going to happen 8 times. So menu 55D, so 8, proper success, 3 over 14, and that's happening no times. And the answer to that is 0.14525, so the probability of y being greater than or equal to 1 is equal to 1 minus 0.14525, which is equal to 0.85475 to 5. Actually, might not be. It's exact. It's exact. Sorry, so I don't need to round it. Okay. That's that. However, you could have done menu 55E, and number of trials being 8. Probability success is 3 out of 14. Lower bound is 1, upper bound is 8. Push enter, and you get exactly the same number if you use the calculator. So that was worth 3. Oops, why is that not gone red? So question part C. Either a green ball or a yellow ball is chosen from the bag less than 5 times out of 8 draws. So I'm just going to say either a green or a yellow. So probability of getting yellow or green is 11. So it's 11. So the probability of a yellow or a green is equal to 11 over 14. And I'm just going to say, I'm going to call this Z is equal to yellow or green. Select it. The number of, and it says it's got to be less than 5 times. So we're saying that this has got to be less than 5 times. And I'm just going to do, on the calculator, menu 5, 5. You could just say that's equal to, if you wanted to, it doesn't happen at all. Happens once, twice, 3 times. So menu 5, 5E. Number of trials is, I think, did I say it was 8? Yeah, 8 draws. Probable success is 11 out of 14. The lower bound is 0, the upper bound is 4. And I get 0.070332 to 3, 4, 5, 6 significant figures, and that was worth 3 marks as well. So I'm now up to D. D. Which rule should the person choose to play by if he wants to win? Justify your answer. To win a game, a person can either choose to play by one of the following rules. From 3 draws, do not select a green ball. Okay, so let's do rule A. Now, the probability of the probability of selecting a green ball is 5 over 14. So probability of a green is equal to 5 over 14. And we have 3 goes, and we've got to, so we in 3 goes we don't want to select, we do not want to select it. So we could just do, so we'll just say 3 goes, selecting it none, 5 over 14, selecting that none, times 9 over 14, selecting that 3 times. Again, that's just simply menu 5, 5D. Number of trials 3, probability of success 5 over 14, and the answer, the x value is 0. That's equal to 0.265671, rounded to 6 significant figures. And rule B. From 5 draws, select a yellow ball each time. So yellow is equal to 6 out of 14, and so it's 5 choose 5 times 6 over 14 times by to the power of 5 times 14, so it's 8 over 14 to the power of 0, and that's equal to 5, 5D. Number of trials 5, probability of success 6 over 14, x value 5, and that's to 0.014458 to 6 sig figs. So clearly I want to choose, it says, just to double check I got it right, yeah, this is the one I want to use, that one there, and that was worth 4 relatively straightforward marks. And then finally, we want to do on this question, I need to do part E. 2 draws are made from the bag. Calculate the probability that given that the first ball was not green, the first ball was not a green. Oh yeah, I remember I changed that, didn't I, to say second. So 2 draws are made from the bag. Calculate the probability that given the first ball was not a green. So the second was a yellow. So I'm going to draw something like tree diagram like this. Green, not a green, yellow, not a yellow, yellow, not a yellow. Now, the probability of getting a green is 5 over 14, so that is 9 over 14. The probability of a yellow was 6 over 14. I'm pretty sure I got that right. 6 over 14, yeah. So that's 8 over 14, 6 over 14, 8 over 14. And what we need it to be is the calculate probability that given the first ball was not a green, the second was yellow. So we have to do not a green both routes. So not a green both routes. So it's 9 over 14 times by 6 over 14 plus 9 over 14 times 8 over 14, and the root that we want on the top is that it does say we want it to be yellow. You want it to be yellow, so it's 9 over 14 times 6 over 14, and look how this is the same, and that's how you know you're going to be getting it right. And let's just simplify everything. (54 over 196). So 54 over 196 divided by 126 over 196 is 3 over 7. And that question was worth 4 marks. And that is the end of that question, which took me a long time to do.